Good evening. Welcome to Kopernik Observatory. Great to see you all here. My name is Drew Desker. For those that don't know, I'm the director here at Kopernik, and I'm glad to have you with us this evening. I was going to say I usually do a who's here for the first time, but actually I think almost everybody's been here before, and and most of you are members, which is great. Trying to think, just a brief. I know that some people have been here in a while, so let me just do a little orientation. We just last year finished our 50th anniversary of being a public observatory and science center, and now we're sort of on our course for our next 50 years. Right now, we're in the middle of our school program sessions, where schools will come up here, or we will go to schools with our programs. And so it's always great to have, normally it's pretty quiet up here, other than when the schools are here. And then you can definitely feel the energy rise. Of course, we do our summer programs. We'll have, this past summer was our 33rd year of offering STEM summer camps. And now we're looking toward actually planning for our 34th year. Actually, one of the things we'll be hoping to do is I run a camp called Welcome Aboard the International Space Station, where our students will talk to, they learn about what kind of work, what kind of training astronauts go through, what kind of work they do on the ISS. I talk about satellite orbits and communication, and I arrange through NASA to have our students talk to an astronaut on the ISS using the ham radio station we have here. So hopefully we'll get approved for that again this coming summer. But again, one of my favorite things is actually these Friday night programs. It's an opportunity for us to sort of continue our education. So I know I see some younger folk here in the audience, and it's great to see you, but I want you to look around, because you see there's a bunch of us older people, some of which with gray hair, and we still want to learn. And that's really something that we should all be doing. We should be really striving for to be lifelong learners. And so these Friday night programs give us an opportunity to do that. One of the things also we do with our Friday night programs is we live stream them. So let me just, I got to get to my, no, that's all right.
It's my mouse.
I got to switch the, hold on, Alt-Tab. Here you go. So our website always gives you updated information. In fact, what I'm going to point out here is Vigilia 2025. And Vigilia is actually a Polish, it's the name of a Polish Christmas Eve dinner. So the Kopernik Observatory was built by the Polish people of Polish ancestors and Polish immigrants here in the 1970s that wanted to commemorate Copernik's 500th birthday. And so part of our bylaws are actually to promote Polish heritage. And in fact, both of my parents were Polish immigrants. I'm first generation American. And so we would always celebrate Vigilia, which is the Christmas Eve dinner. So in promotion of our Polish heritage, we always run this Vigilia 2025. And so you can register online. It's a great meal, a lot of fun, and so we make you aware of that. But again, our website, tells you what's coming up. So today's Friday night program is the National Weather Service Summer Review and Winter Preview. You can also get you can scroll down and check out our newsletter. And also, if any of you are educators and are interested in joining our education team, we'd like to talk to you about that. But when I mentioned about our Friday night programs, that we always live stream them. And so if you go to our YouTube channel, and you can actually see the last 5 years worth of programming. Last year we had a program on the Panatel, the area down in Brazil that's the largest tropical wetland, where they have jaguars and capybaras and caiman. The week before that, we had a BU professor talking about Easter Island and how that's the island off of Chile, and how do those large moa stones get placed where they are. So you can check out all of those. But along with our Friday night programs, we also do these live streams when there are astronomical events going on. So if there are meteor showers, eclipses, we often will cover them. In fact, actually, Jenny, our live stream astronomer, who is driving our live stream this evening behind the screen here, was up here in March at 2 in the morning and ran a live stream. But this is a 1 minute time lapse of the lunar eclipse back in March. So you can see the penumbra covering up the moon. Then we changed the exposure so that we can actually see the eclipsed moon. And here it is finally in total eclipse, where that red is actually the long wavelength light, the red light that is coming through our atmosphere. And it's not, and clearly it wasn't the end of the Earth, as is often predicted. And then eventually it starts to fade back to our regular moon, and we had to switch back to the standard exposure. So now we have almost 14,000 subscribers on our YouTube channel. And again, what's beautiful about the YouTube channel is that it also allows us, you can do this anytime. So if you're unable to join us on a Friday night or to watch the live stream, you can do it at your convenience, or you can go back and, in fact, you could look at tonight's program tomorrow. So again, we're very fortunate that we've got some outstanding resources here in the area that we can draw on to provide that education, that continuing education for us. And I've called a number of times on the National Weather Service and Mark Pellerito in particular to come and talk about what's going on in the weather, in the weather areas. And again, when you think about it, how many National Weather Service stations are there? 122, and yet they chose Binghamton to be the one. I mean, there's not one in Syracuse. it's here. I think the next one is down in New York City, or Albany. Okay.
New York City, which is out on Long Island.
Okay.
Buffalo, and then Burlington, Vermont, which gets the North Country.
All right. So we are getting the most accurate weather forecast for our area here. So what I'm going to do now is we're going to switch over to Mark's presentation, and I'm going to turn it over to you, Mark. So 2 clicks on the mic.
All right, hopefully that's coming through okay. Yeah? Okay, good. Ready to roll. Okay, great. So I'm always happy to come up here because I'm a bit of a weather geek, science geek. We're all science geeks here. I like doing school talks and all that. Kids are great and stuff, but not all of them are like really into the science. Where's the crowd here? Oh yeah, you're all into the science. So it's always a blast to come up here. So thank you for coming, and thank you for inviting me here. So we're going to go through a couple of the significant events that we had this summer, and then where things are at now, and then also the big thing, which everyone's wondering, is what do we got coming, right, for this winter. So let's go ahead and get into it, starting with what was expected. When we are going into summer, this was the forecast where you had the probabilities for above normal temperatures for June, July, August, and maybe a little bit of above normal precipitation. Now, that's what it looks like on the big U.S. maps, but don't get too hung up on the colors, because what it actually means is this, where you had a 57% chance of above. Below still could happen. Near normal could still happen. Precipitation was a little more of a mixed bag, but that is kind of what we were expecting. Factors included that we were between La Nina, El Nino, not really one or the other, the computer modeling, and that the tropical season, above normal tropical season was forecast, so you see the above normal precipitation there. So what did we actually get? Well, when it comes to hurricanes, we had an active season, but almost every system was out to sea. So luckily, We got to avoid hurricane remnants this year, unlike very recently, like last year or the year before. And Melissa, wow, was Melissa something else? That really recent one that just nailed Jamaica and Cuba before heading over to Bermuda and out to sea there. So that was a Cat 5, and there were 3 of those this year, which is, getting 3 Category 5 hurricanes in a single year is really, really something. That was the latest in the season ever, also to have an Atlantic Cat 5. All right, so closer to home, we had 6, 7 tornadoes. No. I thought I'd get the young crowd with that joke, 6, 7. Yeah. So we got 7 tornadoes this year in New York State. Last year we had the record 32, and that was really, really something. We got something closer to average this year, which our average is about 9 or 10. So as far as precipitation, we were right around normal, even though it was a little dry as we get into August. Temperatures indeed turned out to be, but June was really hot, June and into July before things settled down a little bit there in August. And then the significant events that we're going to go through is the heat. June 22nd, we had a couple of tornadoes and high-end severe weather just to our north and east here, with flash flooding into Shenango County. And then July 3rd, that's probably the thing that everyone remembers around here the most, because we had a long track supercell with a lot of hail and wind, tons of damage with cars and roofs. Newark Valley flash flood as well. So let's go ahead and step through those. For the heat, now what you're looking at here is a plot of, you see the green? The green range is the normal high, normal low, with, and this is month to month all the way through about August there. So that's normal. And then the records are at the top of the red and the bottom of the blue, daily records. And then the actuals for this year is, you just see this squiggly plot. So you can see here, now you have some cooler dips here and there, but we spent a lot of time with above normal temperatures there, June into July. And unfortunately, we had a heat-related fatality in Owego. This was on June 23rd, where we have this thing called the heat risk, NWS heat risk, which what it does is it compares past conditions, humidity levels, high and low temperatures, and cumulative, not just a single day, but if you have many days in a row, you start taxing the human body, you start taxing infrastructure, the power grid, all that stuff. And so that stacked to get extreme levels in the Twin Tiers, which doesn't happen that often. I mean, getting into the purples, just saying, I know you're not used to looking at this, but the purple category, that's like a once a summer type category usually, if not less. So everything really culminated there, and unfortunately we had a heat-related fatality on that day. All right, June 22nd, we had a tornado up in Clark Mills. It started here in Clark Mills, and then it quickly turned and then headed south to the south-southeast. Lots of damage with it, and unfortunately 3 fatalities, which in New York, tornadoes are not completely unusual in New York State, but deaths from tornadoes, that's just not very common, especially getting 3 out of 1 tornado. It was very unfortunate. You had a very large tree cut through a house like a hot knife through butter, and there were kids sleeping there, twins. And then you had another, like a mobile home where at the end of the mobile home had another tree fall on that. So very, very unfortunate. And that wasn't the only one. You actually had a second one here too. Same event. That's one of our meteorologists, and we were doing our storm survey, and pieces of this barn got lofted and thrown like up to 1,000 feet. So that's pretty something. And this one was 110 miles per hour peak wind, nearly 5-mile path. And let me back up again. The first one was about 2.5 miles and 105 miles per hour. So both of them were EF1 tornadoes, near the top end of an EF1 tornado. I do want to mention something, a little bit of a success story on this one. Hamilton College is right there. We have a close relationship with them. They're a storm-ready university, which means, you know, they've built in some readiness and all that. They have a plan that they enacted. Now, what was so unusual about this? About 4 a.m. on a Sunday morning. So the awareness of, like, you know, a severe weather situation, people getting warnings, that doesn't happen very well sometimes at 4 a.m. on a Sunday morning. And yet Hamilton College, their weather radio went off because of the tornado warning, and they enacted their plan immediately, and they showed me the video of this, the security video afterwards. You could see all the people arriving and getting in, and then wham, it hit. Now, the campus itself ended up just getting skimmed, but the thing about this tornadic situation was that the whole line of storms was making damage. You had the focused tornadoes, but throughout the area, you had 60 to 90 mile an hour winds, and so there were trees going down all over the place. We had 2 serious injuries because, hey, it's a it's a summertime weekend. Of course, people are camping, and you know, if you have a line of storms coming through at 4 a.m. knocking down trees, you're very susceptible, very vulnerable, and so yeah, you had 2 serious injuries from that. So that was, as if that wasn't bad enough, then you had these storms lay out and do a very quick 3 to 6 inches of rain. So you had a flash flood emergency in Chenango County. You had some flash flood warnings surrounding it as well. So, you know, no travel necessary type warning in Chenango County in coordination with the emergency management there. So that was a big day. Yeah.
Where is Hamilton College on that map?
Right about here. So yeah, they got a pretty good amount of rain too. Yeah, they got roughly 3 inches of rain up there. Yeah, and then the highest one, I forget which location, but 6.5 inches there in the border of Chenango and Otsego counties there. And then you had a 6-inch report there in Delaware County as well. So that was a very, very big day. But it wasn't so bad here. You know, we got a quick inch in our area. But then we did get what we had coming, because this happened on right before 4th of July, where you had this long track supercell. What a supercell is, it's a thunderstorm that starts rotating, and so where it's going and where it's getting the energy from are 2 different directions. And so it just can keep going and going and going. It doesn't rain itself out, unlike an average thunderstorm, which just pops up and then rains out and it's done. This just kept going and going. And so we had severe thunderstorm warnings all along the way, and we ended up getting some large hail. My car out in the parking lot it's got a moonscape on it. If you want to see it, it's got dings all over it. Because I was driving into work for this event, and I watched the big shelf cloud coming overhead, and I'm like, oh, I'm not gonna make it, and I did not. But if I had even gotten to the parking lot, it wouldn't have mattered because everybody got hailed on. So this right here is the velocity signature from the radar, which is right there. And so anything that's green is inbound winds. So you can really see the 50 to 60 mile an hour winds, at least that's what it was at that point. In the vertical, you can see that this hail core extended like 25, 30,000 feet. So that dumped down. And before I exit from this thing continued to accelerate. And by the time it hit Otsego Park, it was mowing down trees and throughout the Binghamton area. And then as it continued further, across the state line into Susquehanna County, 90 to 100 mile an hour winds. On radar, it was about 80, but the radar is just seeing the outbound wind. It's not necessarily seeing how that wind's hitting the ground and shooting through a valley, which is what happened there. So it was really, really something. I mean, just hot, snapping trunks, throwing stuff all over the place, all power out, all comms out, no cell phones up. Ham radio, though. Ham radio worked. That's the last stand. You know, if you're down to ham radio, everything else is, you know it's a bad event if you only got ham radio left. All right. So then Newark Valley had its flood. You can see there was this very focused, observed 3.5 to 4.15 inches, but you see that the brighter colors there. That was where it got more like 4 or 5 inches in some spots there, including including Newark Valley, which turned into a bit of a river there for that area of Newark Valley. It was, so very high impact, yet also super localized, very localized area. You had a lot of mutual aid going on. You had people from around here all heading up there to respond. So flash flood warning was out for that, and that turned out to be one of our bigger flash floods of the year. Then things slowed down. As we got into August, the temperatures cooled off to where we were, roughly 1 or 2 degrees below average for much of the area. And then for the precipitation, this is percent of normal precipitation. And you can see most everybody was getting skunked in that department. So things really started to dry out, and you started hearing talk about drought and all that stuff. But lately, it's gotten a little better, especially right here in the Twin Tiers, where this green color is right where you flip to 100%. So we've gotten our normal precipitation the last 60 days. And if you look at just the last 2 weeks, that orange to yellow color is right around 1 3/4 inches to around 2 inches of rain, just last 2 weeks. So remember how we were like, things were getting a little crispy out there, and there was concern about potential for brush fires and all that. Well, that's been all put to bed now, so we don't have to worry about that anymore. The drought monitor, while there's still some pockets of moderate drought, it's better than it was. And certainly right around here, we're back to normal around here. Some parts of New England are still in extreme drought, though, but at least things have improved for us. All right, so that's where we've been and where we are now. And now we're going to get into the good stuff. What's going to happen this winter, a taste of which we just got. I saw your video. Yeah. So before I get into the real nitty-gritty science, fun stuff, the bottom line up front is near average is what we're expecting. Precipitation, snowfall, temperatures, there's no reason to not believe that's going to be somewhere around average, which sounds awfully boring. People want to hear it's going to be really cold and snowy, or it's going to be really warm, the extremes. But no, and there's real science to back this up. I'll show you all that. So it sounds boring, but if you think about it, a lot of our winters recently have been warm. Last winter, not so much, but if you look in the long picture, say the last 10, 15 years, a lot of warm winters. So actually saying something near normal, that is saying something. Good old-fashioned winter. All right, so, and I'm going to take a step back again. I know we keep going back and forth here. We just did summer, and we were going to winter, but wait. We're going to go back to last winter because there's reasons to do that. I'll show you. Last winter, this bar chart here is La Nina, neutral, or El Nino. The blue is La Nina. What is La Nina and El Nino? So right here, this is the Pacific Ocean, and that's the equator. And you see the blues there? That's below normal water temperatures. And so that's La Nina, when you have below normal water temperatures around the equatorial Pacific. El Nino is the reverse. That's when it's warm. So our situation last winter is that we had a weak La Nina, and that's what we were sliding into, and we were expecting these are 3-month periods here. October, November, December, January, December, January, February, January, February, March. So you see the blue? That means that La Nina is what was expected, even though it was on the weak side. So our forecast, this is a typical La Nina pattern where you have the jet stream really kinking up across Alaska and then back down, and then back up across the northeast again. So what that means in a La Nina pattern is we're in the storm track, and things are going back and forth a lot. You get the warm air coming up, but then you get the access, importantly, to the cold air coming down every once in a while. And so the lake effect was very active. So this was the expectations for last winter, where, sure we're in the orange, but that's you're only talking about 33, 35 to 40% chance of above normal temperatures, and you'll see in a moment that we ended up right around normal. Precipitation outlook could have gone either way with the above normal out in the western Great Lakes. La Nina pattern also has below normal precipitation and temperatures in the south. They can more bank on that, whereas for us it's a lot more iffy for El Nino, La Nina. So this right here, It's not just showing that the Tug Hill and Great Lakes made more snow. That happens every winter. But this was more than their normal. So it was very active. You had some areas on the Tug Hill and Utica northward. They had 200, 250, 300 inches of snow for the season. They had so much snow, like in northern Oneida County, for example, and over into Oswego County. They're used to snow, right? So for them to have structure collapses because of how much snow they were getting, I mean, that's pretty epic. So they had a very busy season up there. And downwind of Lake Erie, you can see some of the high terrain there as well. But around anywhere outside the lake effect zones, it was somewhere a little bit below average. So what we got last winter in the details, lake effect was active, but areas not prone to lake effect generally had less snow than normal. For Binghamton, right at the airport, which is similar to here because, not in town, but up on the hill, you had the core winter months, December, January, February, right around normal. For the precipitation, temperatures was not even a degree shy overall. It was just pretty near normal. The core months for snow was like almost right dead on average. And then if you do the snow total, like November all the way through March, so the entire season, just short of average. 86.5 is average for inches, and we had 80.1. Now, Binghamton is, at the airport, a little bit susceptible to some lake effect snow coming down from the Finger Lakes or even some continuous flurries off of Lake Ontario. So you get in the valleys, though. You get in the valleys, not so much. 37 inches in Green, 25 inches in Corning, Newark Valley, 36, 37 inches. So a little bit short of average for them. And they're usually less than the airport anyway. So that's what we got last winter. Why am I talking about last winter? Because this winter setup is not a lot different, at least in terms of El Nino, La Nina. We are in a La Nina right now. The difference from last winter is instead of sliding into it, we're already in it. You can see all that blue there, below normal water temperatures. It is weak, though. Here you can see the energy in the upper ocean. And so last winter we were in the same spot we are now, but we went deeper before coming back, whereas now we're kind of shallow and we're expected to slide out of it. So we're going to start winter in a La Nina, and we're going to fade it with time. So that's one of the factors. Now let's take a look at the past again. We're going to take all of, if you take our current situation for La Nina and say, okay, let's take all the past, not the strong La Ninas, just the weak to moderate ones. And if you do the core winter months and you look at those past cases, you see a lot of variety. So the reason I'm showing you this is even though the expectations are somewhere in the middle, there's a lot of variety of what could actually occur. And I hate to say that as a meteorologist. I like to say, here's what's going to happen. What I'm telling you is I don't really know what's going to happen, and nobody does. There's just sometimes the signals are really waffly, and that's the situation. And when you look at the past, that's what's hinted at, what's happened in the past given the current setup. Precipitation, same thing. All over the map. The greens are above normal. The browns are below normal precipitation in all these winters here. And so you see here's some above, here's some below, lots of middles. Anything could happen. All right, so while we're talking about the past, let's do something a little more detailed on our level instead of the big U.S. maps. We're going to focus on specifically weak La Ninas and other factors that we look at too, which I'm not going to dive into for this talk. There's something called the quasi-biennial oscillation, or QBO. There's the Pacific Decadal Oscillation. And so if you look at all those plus the La Nina winters, you come up, and you also skew it to the more recent ones to make it more relevant. And you come up with these winters here. This is what our winter program leader in our office, his name's Mike Murphy. Drew, you've met him. And he's done a talk here too a couple years ago. So he along with Mitchell Gaines, they picked these winters as being the best matches for analogs. What happened in the past. And when you do that, and you take these are not forecast maps you're looking at here. You're looking at past maps, past cast, I guess you could say, of specifically those winters and what happened in December. Temperatures right around normal, just the tiniest hint of above, the first color there off of normal. So right around normal there. Precipitation, you see this hint of green. So there's a tendency to try to be above normal, but not by much. In those winters, you put them all together. Now remember, that's just the average, mean of the extremes. And you saw on those other maps, a lot of flip-flopping all over the place. January, somewhere around normal, maybe just a smidge below. Precipitation right around average, maybe just a smidge below. Not by much. And precipitation, I don't mean snowfall here. I'm talking about the liquid of everything that falls, liquid equivalent. February, there's something a little more, there's something to point at here, a little more for the past. In the past winters that had this setup, you had a pretty big thaw across the southeast and extending into the northeast. Precipitation right around average. If you go downwind of the Great Lakes, maybe above, but you get towards the cities, below average. So that's going on a little bit detailed look. And then March, near and near. But we're going to broaden this out now. The core winter months overall, 3-month averages, December, January, February, of those past analog years. And you see just the tiniest shade above when you average all those winters. So that's pretty much near normal. Precipitation, pretty much near normal. All right, so that's looking into the past. Oh, and this is just forward 1 month into the later months, January, February, March now. Near, and then this starts to show up a little more drier south and east of here. But for us, right around normal. Okay. Now we're going to look at the actual forecasts instead of the past casts. And the actual forecast, if you look at the long-range guidance, you see some signal here for, even though it looks red, which is scary, deep red, it's just a degree Celsius, a degree above normal showing up there, especially in the south. And then you look at the precipitation, we're right on the margin, where the Great Lakes above normal, and then southeast below normal, which is typical La Nina pattern. Now we're going to calibrate this to more of a probability. Instead of an amount, we're going to go with a probability. What are the probabilities of above and below normal? And you see this, very light shade, which like, does that mean something? Well, okay, kind of. If you put you got 3 buckets here. You got the above normal bucket, the below normal bucket, and the near middle bucket. And all this means is like, okay, somewhere around 45% chance of above normal temperatures. And then the rest of it either near or below. So that's a non-committal forecast, even though there's a lot of orange. What's more committal is down here, over there, and then for precipitation, no clear signal. You get to the western Great Lakes, and there's more of an above normal precipitation signal showing up. But as is typical with La Nina, very dry in the south, and then extending up to the mid-Atlantic, but not as far north as we are. Okay, there's other cycles too that I'm not going to get into. El Nino and La Nina is the easiest one because it's a big barge that slowly moves. You can see where it's probably going, and you can see where, if it's turning and all that. Whereas all these other cycles, they turn on the matter of days to weeks, and they're pretty hard to predict. As you can see, even our modeling, these are the observations, and the modeling you can see immediately spaghetti's out to where it's like, which one's correct? Who knows? There's just a lot of spread. So there are other cycles, but the main point I'm making here is if you have a strong El Nino or a strong La Nina, it tends to override your pattern. But we don't have that. And so these other cycles, which are harder to predict and more uncertainty, are going to be what's in charge this winter. An example of which I'm about to show you because we actually have something in the next few weeks here, at least that we're looking at right now. All right. So let's put it all together. The actual official forecasts. First, starting at the 6 to 10 day outlook. This is November 20th through 24th. Our recent cool spell that we've been having, and next couple days also kind of cool. Well, we're going to get back into a warmer pattern, and actually, precipitation-wise, looks like it's going to be a little busier. I do want to say before I show you more of these maps, how to actually read them, because it's easy to get hung up on the colors And does this mean, much above normal? Or is it just by a number of degrees or what? What it really means, and it's not telling you by how much above normal, what it really means, if you look at it on a local level, think of it in pie charts, again, the 3 buckets, where you got the above normal bucket, the below normal bucket, and the near normal bucket. And so if you're in shades of red, that means the red part of your pie chart's getting larger. But that doesn't necessarily mean you can't have below normal. That could happen. It's just the odds of it are pretty small. So it's more of a probability map than an actual ironclad forecast. Precipitation, we're in the green, but it's not as dominant of a green. So below to above normal there, you can see that the odds for above normal are nearly twice as much. But then you get the near normal bucket, which is, it could pretty easily turn out to be around there too. So that's how to interpret these maps I'm showing you. All right, let's go to the Thanksgiving map. And this, granted, this is an entire week that you're looking at, 22nd through 28th of November, and you can see there's a pretty clear pattern of where the jet stream will probably bend down in the west and come back north in the east, and so we're more favored to have above normal temperatures during that time period. Precipitation, we're green, but barely. So I wouldn't put too much into that. Here's the pattern change we're seeing. One of the cycles we look at is starting to indicate there's this thing called sudden stratospheric warming event, and it's something you can start see the hints of a couple weeks ahead of time sometimes. So that is one of the things we're looking at, and it's pointing to a spill of some pretty below normal temperatures, at least in the northern plains and extending into the upper Midwest, western Great Lakes. And then with time, that may spread east. So I'm not saying we're turning red on Thanksgiving. It doesn't look like that. But as we get deeper into December, beyond a few days into December, there are some hints that we may have one of those. These maps I've been showing you, they're averages, 3-month averages even. That doesn't mean you're not going to have a battle, back and forth. All winters have lots of back and forth. And one of those backs for the back and forths looks like could be potentially taking shape for early December. So be ready for that. And also the above normal precipitation is showing up as well. So could be a busier period, both in terms of do we have a system or two coming up the coast, and we're on the backside, cold side of that? Do we have that? And even if not, okay, well maybe we get into the cold air with lake effect streamers and lots of fluff. So that's something to look ahead to. But we do get through Thanksgiving first, I think, before we have to deal much with that. All right, now these are the official forecasts. November, December, January, the leading 3 months of the winter season. And you see that the precipitation could go either way, somewhere around normal. And then you see we're technically orange, but again, this is a 3-month average. You're going to have a lot of battling back and forth. And this is the lightest shade of orange, which is only up to about a 40% chance of legit above normal temperatures. It's almost just as probable that you could have near or even a little bit below. So that's what it looks like there on the leading months. And then once you extend that into the core months of winter, December, January, February, well then it's near and near. So it could go either way. And then once you lean towards the later winter, January, February, March, somewhere around normal is what is, or equal chances of any of it. So with the somewhere near normal probably being at the peak of that. But a lot of variety and a little more uncertainty than normal.
So Mark,
yeah.
Every month has sort of its own quote unquote normal or average temperature. Mm-hmm. So so I don't know if you sort of know this off the top of your head, but it's what would be the normal average temperature for December, for January, from February?
Okay, good question off the top of my head. I'll have to come up with that in a sec. Yeah. No, it's fine. It's solely fair game. In fact, let me go back a few slides because I thought I had some digits here. Hold on. Okay. So, if you went with a single temperature, and this is the average of highs and lows for a 3-month period, that bottoms out at around 25 degrees. And also, even though the shortest day length, longest nights, December 21st, but that doesn't mean that's the coldest period. There's usually a lag on that for like a month or so. So the actual coldest temperatures of the winter on average is more like mid to late January before things start to turn. Okay, so that's a shorter answer for you, but I could dig up more answers for you on that towards the end. Okay, let's see, getting back to where we were. Okay, that's the 8 to 14. There's the pattern change. There's November, December, January overall. December, January, February core months. Later months of winter, January, February, March. And by then, this is when we're pretty much probably out of La Nina. We're somewhere in the middle. And so is our forecast, somewhere in the middle. Okay, back to what this means for snow, which is what usually everybody likes to talk about the most. All those precipitation maps I showed you, that's not the type of precipitation. That is just precipitation overall, liquid equivalent. Let's see what this means in actual snow. The average snowfall patterns for all La Nina years, or at least up to 2009, 1950 to 2009. And so some things show up here. It's like, okay, oh, more snow up here, less snow in the south. Of course, I knew that. Well, yeah. But this is compared to their averages, not total amount of snow here. So compared to even the average of, like, say, up north there, Tug Hill, they get more than their average for the La Nina winters. And you see this, below normal extending up to the Catskills. So this is, again, not a forecast. This is looking at all past winters that are La Ninas. We can do better than that, though. We're pretty confident it's going to be a weak La Nina. So let's go to weak La Ninas. And when we do that, the lake effect, and I know this is kind of coarse, some of these blockiness, it's just a matter of the resolution of the data set. But the lake effect zones really pop out in weak La Ninas, as we just experienced last winter, where Tug Hill just got completely bombed. So that's something I think we'll have to kind of keep an eye on, even around here, because sometimes the lake effect, it'll end up shifting low finger lake bands down here, and we get nickeled and dimed with fluff day after day. That could happen. But you get outside the lake effect zones, and there's not a clear signal in any direction. So overall, again, no reason to expect something that extreme one way or the other. Somewhere in the middle is what's most likely. Which, given all the warm winters we've had recently, is saying something, right? Okay, I do have digits for you on this. This right here is your 30-year average of snowfall. And so talk about something I can't give you a single number on. And on average, you're talking anywhere from 45 to 90 inches. And as you get up to, like, say, Tully, they're well past 100 inches in an average year. Syracuse, too. Tug Hill, there are places that, on average, get 200 inches a year. So I can't give you a single number on that, but I can tell you that it is highly dependent on two things: elevation and access to lake effect moisture are the two major factors of all these differences here. And so even though at Binghamton Airport we're like around 85 inches, Binghamton City, our average is probably more like 55, if that. And you can see Owego there's short of 50. So that's your average. And so if I say something around average for a season snowfall, it may look a lot like that. Here you can see Tug Hill. The top Tug Hill value that we have for a 30-year average is 227, probably around Redfield. All right. Okay, and then to bring this home, I'm almost done here. We're going to remember the analog winters, the ones that were the closest match to our current situation. When you look at those analog winters, and it's like, okay, if you take the average of those winters, it's really close to average, 97% of average. Our 1991 to 2020 mean is 87 inches, and these winters are around 84, 85 inches average. Here's the key point. Look at the variety. Average doesn't tell the story. Spread tells the story. anywhere from 61 to 134. So that tells me uncertainty, which I hate being uncertain as a meteorologist, but it's the truth. So when you look at the past there, your hint of the past is that it's more of an anything can happen situation. All right. So again, I already told you some of this up front, but generally near average winters, precipitation and snowfall is considered what's most likely, and yet there's a lot of uncertainty. Precipitation, total liquid, again, equal chances of being above, below, or near. Past La Nina winters tend to have a lot of lake effect being even more important than normal. And then outside of lake effect zones, near or even a touch below average is what's it's not the only outcome we look at when we see the past, but that's what's the more probable. And also the wintry mix with the ice, that can certainly battle its way in and out of here. A lot of fluctuations. All right. The last thing I wanted to do, I did the summer review, winter preview, is spend just a brief moment. Do I have time? Am I good? Okay. To plug this program, which is not a Weather Service program, but it's something we love and we promote because a lot of people benefit from it, from academia to the National Weather Service to anybody else. Thing called CoCoRAHS, which stands for Community Collaborative Rain, Hail, and Snow Network. Back in the late 80s, there was the Fort Collins flood. I don't know if any of you ever heard of it, but the situation was there was some rain in Fort Collins, but just a few miles west, there was so much rain. I want to say 10, 12 inches of rain. And so Fort Collins, not realizing it was a big-time flood situation because it didn't necessarily fall on top of them, all of a sudden had this deadly flood sweep through town. And somebody had the idea of like, man, we really need to know more about, not just what's falling at the airports at official sites, but what is falling across the neighborhood anywhere from nothing to an inch, just a couple miles apart. So they came up with this thing called CoCoRAHS, and it started in one state, and it kept spreading and spreading, and now it's international. It is especially United States and Canada, but there are other places too. And so the more that we get people, the more that CoCoRAHS has volunteers, the denser this network gets and the more information everybody has. So what is it? If you already have your own plastic rain gauge and you're keeping track of it just for funsies and for growing your garden or whatever, there are people who would love that information. Or if you have kids and you want to involve them in a little project or anything like that, you would report daily how much precipitation falls. And then once you do that, you get a pretty handy map, and everybody gets a handy map. There is training on this for what you need to do, what you need to use, and how to make your reports. And I'm just going to show you some live data on this too, just to demonstrate how cool this is. All right, so now I got a mouse. Hold on. There we go. And while that's queuing up, I got these. Do you mind passing these around? Thank you. Okay, so here's if you click on the map, you end up getting a zoomable map where you can say, oh, here's how much has fallen, which is handy for anybody who needs to know. But hey, how about, remember that the flooding day? You can go back in time. You can say, hey, what happened on June 22nd? And I think I hit refresh. No, I guess I did that wrong. Hold on. Or you can do ranges too. You can do multiple days, whatever you want. All right, I think I need to click yeah, there we go. June 22nd. And you zoom in, and it's like, holy moly, there's all that rain, at least for the CoCoRAHS observers. It's not, all the airports and everything else. This is not radar estimates. These are actual observations. What these values also do for us at the Weather Service is like is our radar estimating right? Sometimes it does better in some situations, sometimes not. So that helps us there. Radar is a man-made instrument that can fail. What if our radar's out? And we're depending on a radar far away, and we need better rain estimates. Now we got them. And also if we get big reports from CoCoRAHS, it comes straight into our system, and we can send it out to all the media so that they know and they can report what has fallen. So, and as I just demonstrated, you can bring up anything going back many, many years. It's pretty neat. If you, let's see, another one that comes to mind is, let's say December, was it 19th, 2020? Anybody remember what happened then? Winter 5 years ago, 5.5 years ago, whatever it was. Oh, I did the wrong thing again. I got to select. December, okay, I tried. Oh, it did come up, didn't it? Okay. So you are looking at, no, wait, it didn't come up. I'm thinking of the big 40-inch snowstorm that we had. Yeah. So December 2020, 19th. Okay, that's the 19th. Maybe I have to go one more day up to actually catch it. Am I in the wrong year? 17th. Let's try that. Now we're talking. Okay, so this right here, this is just liquid equivalent of what fell. We can change this to snow, I believe. Let me, oops, what did I do? Yeah, so this is the liquid equivalent of what fell. But you can, here we go. Let's change it to snowfall. And update map, there we go. Look at that. 42.5. These are, 24-hour amounts. I mean, that's, talk about crazy. So you had, 2 to 4 feet of snow fall in a stripe, extending from Pennsylvania right through the gut here, Twin Tiers, on up I-88. So you can bring all that up. I mean, it's just, and why can we do this? Well, it's not us. It's the CoCoRAHS volunteers and the program that we are one of many beneficiaries of. So I just wanted to plug that. If you're really into this and you track your weather already anyway, or you want to start something new, that is something you can do. Yep.
I was going to ask when it started, and it said something around 2010. But I heard you speak a couple years ago here, and I don't remember you saying it. I don't remember you saying anything about it then.
Yeah.
Is it newer now to this area?
No, it's been around for a while.
Okay.
Sounds
like a great idea.
The infancy of it was in the late 80s because of the Fort Collins flood. And then the 90s it started to take off and spread. And now it's been around for quite a while. That said, we do have some gaps in the data. The more we can patch this in, the better. You saw that map, for example, the Pennsylvania map from like 5-6 years ago with the snow, the heavy snow, and there were some pretty big gaps there. So yeah, the more data, the better. As far as getting better forecasts done, better lessons learned from each system, and just monitoring things like drought conditions and all that. How much rain is helping fix that, for example.
So
yeah.
I mentioned that our live stream, we get people from literally around the world, and Lindsay, our good friend down in Adelaide, Australia, is actually on right now.
Yeah.
And so I'm wondering if actually CoCoRAHS might be available down in Australia.
I don't think it's that international yet. Let me go to the CoCoRAHS page, and let's hit Join CoCoRAHS. And when you do that, it says, okay, United States, Canada, or Bahamas. So
All
it's
right.
not
So it seems
that
like it's
international.
all right.
Sorry.
All right, but maybe it's something that hopefully. I mean, I would imagine they
There
could
could be a
benefit from that.
CoCoRAHS equivalent down there
Right.
I'm aware of.
Yeah,
I just
exactly.
don't know.
Get that started.
Yeah. Go down and help her out.
Yeah.
Uh,
Or the Bureau of Meteorology that they have down there, they might have their own
some
spotter program
some
or
parallel
what have you,
kind of thing.
like maybe a Skywarn equivalent.
So no, it seems like there's a lot of people that have their own personal weather stations. We have one up here at Kopernik.
Yeah.
I have one in my home.
Mm-hmm.
That I just happen to use what the Davis weather system, whatever,
Mm-hmm.
that publishes on like Weather Underground.
Yeah.
And so, is that is there any hooks into that at all, or
For CoCoRAHS specifically, like in an automatic sense, I don't
Yeah.
think so.
okay,
That said, things that like get put into Weather Underground and other things, we do get that at the Weather Service.
okay, so
if
you
we're-
can pull from that.
What's that?
You can pull from the Weather Underground.
Yes.
Yeah. All right.
Yeah, I'm not sure the technicals on that. I'm not the right guy on that.
Okay.
But I know we get a lot of citizen observation platforms
Based on
coming
that.
into our system.
Right.
Coming into our system.
Right.
Yeah.
Very cool. Are there any other questions here locally? Just going to check the chat here. Nothing current. Anyway,
Okay.
well, Mark, thank you once again for
Yeah.
coming up and telling us about what's going on here.
Pleasure's all mine. Thank you.
And so next week we have another. If you could switch back to the other. As soon as my computer comes back to life. And are we going to come back to life? Hopefully. Talk to me. There we go. So if you go, again, if you go to our website, here we go, and go to public programs. And next week, our talk is going to be the power of collaboration, economy, well-being, and the environment. And it's Jeff Smith, who is part of Rotary and also Enrage and the Tier Economic Network, talking about a holistic strategy for community growth. So, again, we'll also be open regardless of clear skies, but we will hope for clear skies. Ashley, can you tell me, are we socked in, or are we? Do things look good outside? Otherwise, I was just going to say, I want to make sure that you check out Saturn, and I think Jupiter will be coming up in a little bit as well. You may be able to grab that before you head home. So, otherwise, Mark, thanks again, and thanks for those watching on the live stream, and we'll see you next week.